Welcome to The Explainer. Today, we're diving into how AI is about to completely transform one of the most complex manufacturing processes on the planet, semiconductor lithography. We're going to look at a master plan that's not just about speed, it's about totally remastering the daily life of an engineer. You know, in the wild, ultra-precise world of making computer chips, we're at a point where engineers are hitting a wall. And this wall isn't made of silicon. It's a wall made of pure data. And it's getting bigger, faster than any single person can possibly climb. And to give you a sense of the scale here, just one of these advanced lithography machines can crank out terabytes of data every single day. That's a complete deluge of information for the very experts who are supposed to be analyzing it. The process has literally outgrown our human ability to keep up. So yeah, this is way more than just a little challenge. It's a fundamental shift. The old way of doing things, the manual approach to engineering, is just buckling under the pressure. It's forcing a complete rethink of how these places operate. For years, engineering in these massive factories, or fabs, has been all about an engineer's personal experience and a big book of rules. But that model, it's breaking. We're seeing this massive shift to a new paradigm, one that's built not on experience, but on raw data, not on rigid rules, but on smart, adaptive AI agents. So the big question is, how do you even build an AI that can handle this data tsunami and actually help an engineer? Well, it all starts by creating a totally new kind of foundation, one that lets the AI see, read, and understand everything that's happening in the factory. First things first, you've got to break down the data silos. I mean, modern fab is filled with tools from dozens of different companies, and they all speak their own digital language. It's chaos. A unified namespace, or UNS, acts like a universal translator, taking all that jumbled data and organizing it into one clean, structured language that an AI can understand in a heartbeat.
Next, you build the AI's brain. Now, you don't just plug this thing into the internet, no way. You give it its own private, secure library packed with decades of expert knowledge, all the manuals, all the reports, all the real-time data. And this is crucial. You put up strong guardrails, making sure this powerful new brain is laser-focused on its job and never, ever touches sensitive chip design data.
Okay, so we've laid the foundation. But what does this actually look like in the daily life of a lithography engineer? I mean, how does this AI copilot actually change the game for them on a Tuesday morning? Let's get into it. So let's start with a really core and honestly really tedious task called FAM analysis. This is where an engineer has to manually hunt through thousands of microscope images, looking for tiny defects to get the machine's settings just right. It's like being asked to find one specific grain of sand on a huge beach. It's slow, it's exhausting, and it's easy to make a mistake. Now, check this out. When an AI copilot takes over this job, the change is just staggering. A task that normally eats up 4 hours of an engineer's day, that's 240 minutes, is done by the AI in just 10 minutes.
Yep, that's a 95% reduction in time. And it isn't just about being faster, it's about being more consistent. The AI doesn't get tired, it doesn't get distracted. Human error is basically taken right out of the equation, preventing some really expensive mistakes.
Okay, let's look at another nightmare scenario. A sudden drop in production yield. Nobody knows why. This kicks off a frantic, painful investigation where engineers have to manually dig through the history of hundreds of different tools, trying to find that one common thread. This can take an entire week. It's a total fire drill. But with an AI yield investigator, that week-long search for a needle in a digital haystack, it gets compressed into a single hour, 1 hour. The AI just traces the path of every bad batch and instantly flags the source of the problem.
Even something as simple as an equipment alarm gets a massive upgrade. Instead of a vague, useless alert like temp error, the AI gives you real context. It says, hey, the temperature in chamber 4 is too high, and I'm 95% sure it's because of an exhaust pressure problem that started 30 minutes ago. It gives you the what, the where, and a likely why. So, the bottom line here, this kind of insight leads to a 50% reduction in the average time it takes to fix equipment. For the factory, that's less downtime, more money. For the engineer, it means fewer of those dreaded late-night emergency calls. All right, so let's zoom out for a second. These incredible gains for one engineer don't just stay in a bubble. They create a ripple effect that starts to optimize the entire factory. Because the AI can see everything at once, it starts connecting the dots in ways a human team never could. We're talking about things like perfectly matching the performance between different tools, intelligently scheduling wafer batches for the best results, and even automating those tedious shift handover reports. It's just a cascade of improvements.
And the numbers for the whole fab are huge. We're looking at a 5 to 10% boost in the number of chips coming out the door, a 30% drop in those critical chip-killing alignment errors, and using 30% fewer expensive test wafers. And for the engineer, the quality of life boost is real. You know that dreaded last hour of a long shift when you're exhausted, but you still have to dig through data and write up a detailed report for the next team? Yeah, that's gone. The AI just prepares a draft for you. You review it, maybe add a note, and click send.
You see, this isn't really just about making things faster or easier. It's about fundamentally changing what it even means to be an engineer in this field. It's a whole new era. The AI basically liberates engineers from the drudgery, from the endless searching for data and doing the same repetitive analysis over and over. It frees them up to focus on what people are amazing at: creative problem solving, real innovation, and making the big strategic decisions that push everything forward. And this isn't some crazy flip-a-switch dream. There's a very clear 3-phase master plan. You start with quick wins, like chatbots that help with standard procedures, so you get value right away. Then you move into deeper integration with things like the AI analysis tools we talked about. And finally, you aim for a full transformation, a truly autonomous factory. The end goal is to create an AI-first factory. And this isn't just a cool tech project, it's a strategic necessity. As this quote says, these AI applications are going to be the decisive weapon in the semiconductor wars of the future. The companies building this stuff today are the ones who are going to win tomorrow.
And that leaves us with one last, really powerful thought. If you let AI handle all the known problems, all the data crunching and tedious tasks, what incredible, undiscovered problems will our brightest engineers be able to solve next? By automating the known, we are freeing up human genius to discover the unknown.